Hello, Jeremy here. This is episode 27, and we're going to be doing tile maps. Okay, what is a tile map? This will be easier to show you by looking at a tile editor. If you look for Tiled, the tile editor, I'll put a link to it in the description. You'll be able to download a third-party tile editor. That way we won't have to program something. It's pretty involved, and I don't want to program something like this. So think of it as a tool for game development. Okay, so here we go. Let's open up GIMP. Okay, so here's GIMP. This is showing you a tile set. The tile set is a set of images that we can slice into rows and columns. So this is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is 64 by 64 pixels per tile. And you can see we have some extra leftovers here. The idea with a tile map is we say tile 0, I want to place at a location. Tile 1, I want to place at a location. We're going to make a map from these tiles. So we're able to construct levels from these tiles. I'm going to construct a dungeon with these tiles that I found online. This was an open source tile set that I found. So using the tile editor, I'll go to the tile editor. We'll import a new tile set, and we'll make it test for now. Browse. I can't see that. That's unfortunate. Can I do something? Huh. Yeah, I can't do that. That's a problem. I'm not unhappy. Okay, well, I'm just going to go and find the tiles, the same image that I showed you in GIMP. Images, not media development images. And then it'll go through the wall sheet. And then it asks me to save. I'll call this test. Same path as before. This is really annoying. I can't see this stuff. It'll just put it here. Save. Okay, so we're back here. Now what we want to do is we want to go ahead and create a new map from this tile set. We're going to make it, well, we have 1,280 divided that by 64. That's 20, so we can do 20 tiles wide by 768 divided by, wait, it's 720, 720. Clear out the calculator. 720 divided by 64. 11.5, so let's do 11 tiles high. Let's say that's test. Yep. Here. Okay, so here's the tile map, and you can see there's lots of clunky stuff. That's a layer. We don't care about layers. We only have one layer. I want to get room for the map so you can see what's going on. Okay, so here's the map. Here's the grid for the map. And we just can place things. We can go, I want stairs here. I want a corner here. And you can paint a room this way. And this is how level design can be done. I'm not going to do this for too long. I just want to show the idea for this thing. Okay. We find the edges, like so. Another edge, like so. We put in the ground. And that will make a room. A pretty basic room. I have pre-done one of these tile maps, so we can use it in what I'm going to do going forward. Another thing we're going to have to do is you're going to want to save it, and then you want to export as, and then export as a JSON file. Exporting it as a JSON file will allow us to go test.json and use this information to use it in our actual game. So now I'll show you how I'm going to link the data this tile map will produce and get that into our game. Alright, I'm going to get rid of the tile editor. We won't be needing it anymore. Alright, go ahead and pull up Linux. Alright, so I have the, no, I don't have it in there. I copied it over. I had a test done, but I didn't save it in the right place. Okay, so we need to move Dungeon over to where we are. Development. Yeah, I can move it into here. Okay. Alright, I'm moving dungeon.json over, copying it over, and dungeon map. Okay. So let's pull it up onto my editor. Dungeon. UNGEON JSON. Just ask the match. Yeah. It's just be stupid. Okay, so this is the tile set. This is information for the tile set. You notice it looks like a dictionary because that's basically what it is. Also, let's go ahead and pull up dungeon map. This is the information for the dungeon map tiles. Okay. Make it easier to see what's going on. So here, this is just straight up the data. Each one of these, so this is tile 6, tile 3, tile 3, tile 5, and so on. So we will need to use probably the sprite grid to slice up the tile set, and then use the tile map data to place sprites on the screen and render them out to the background. So we should have effectively just a background image when we're done with this that we can put on the screen and use, and then we'll have our character walk around in it. So that's the idea here. And you'll notice that we have a height of 15 and a width of 22. So this map was a little bit bigger than what we have. So it kind of goofed. But okay, we'll use it anyways just to see how it looks. We can modify it later. Okay, so first of all, we need to be able to read in these files. Okay. So now to do that, we go into our RPG code. We want the background to be changed, so let's just start here. Let's say we want our dungeon, our tile set grid is going to be a sprite grid, and sprite grids are defined by the image to the sprites, and then its columns and its rows, and then its columns. So this is going to be our image. Then our rows. We had how many rows? Oh, it's actually in the JSON file. It should be there. So let's read the file here. Let's do these based on what's in the file. Okay. Tile set. Tile set data. No, let's do tile set. JSON.loads. Dungeon.json. And we need to do file. Okay. I believe this will do what we want. So we should be able to get all of them. Thank you. Oh, that's what it's thinking about. And this will be tile set. Tile set of some key. And then tile set of some other key. That's going to be the rows and the columns of the tile set. And this should be the tile set of whatever the image file is in the tile set. Okay, well, let's go ahead and print tile set and return here. Now when we run this in the REPL, it will allow us to see what's going on. I forgot to import JSON. Well, that's, let's show you. It's a simple line, but it should be shown. Import JSON. That's it. Now we're going to go and save it and go back to the REPL, looking for something else. File is not defined. Okay. That's fine with me. probably open. Sometimes in Python I get Python 2 and Python 3 confused. Python 3 has file in it. I mean, Python 2 has file in it. Python 3 currently does not. Okay. Go back to the REPL or the interpreter. Okay. It's an object must by string, so we need to do one more thing. I was hoping that the JSON load would work correctly, but we need to do .read. This will read all the data from the file and return it as a string for JSON.load, which stands for load string to load. What JSON does is, JSON stands for JavaScript object notation. And it's a very simple object notation which lots of programs know how to import and export. So you'll be using this quite a bit to transfer data objects between programs. So that's what we are doing. We're transferring data objects between the tile editor and our game. So this is a way that we can load in the tile set. And now, when we go ahead into the REPL, or run Python, and did I not save it? I didn't save it. Okay, there we go. So this is the dictionary that we read in. So let me be more clear about what's going on here. When you read in the file, let's do it in the editor actually. Not in the REPL. Python import JSON. So when we go and we say open dungeon.json.read, what we get is the string. So here's the beginning of the string. And we get \n, so that's a character term. So we get the string. You get a string of stuff. Strings of stuff aren't terribly useful, but they can be parsed. And what parse means is to take a string and convert it into an object that we can use inside our programming language. So here we're going to parse the string, which looks like a dictionary, and make it into a dictionary so we can actually operate on the dictionary. Right now this is a string. We said s equals this, and that's s. We say s of 0. We get the bracket. S of 4, we get an O. Alright, so it's just a string. We can't do much with it at this point. However, through the magic of this JSON library, we can do JSON.loads the string. Now we have a dictionary. And now I can say D of margin is 0. S of margin doesn't make any sense because it's not an actual data structure. So when you JSON load something, you're parsing the string into a data structure. There is also JSON.dumps, which dumps a string from a data structure and will dump out a string. So this can be written and saved. The string, the thing that makes it transferable between programs is the string. You can save the string, you can transfer it through different programs. It doesn't have information in the program like addresses to variables and pointers and stuff like that. So an actual data structure inside the computer will have pointers and other pieces of information that won't transfer from computer to computer because things will be sitting at different addresses. So they have to be parsed. Okay, now we have a dictionary here that has the information in it. This is what we need to use. Okay. I'm going to copy this stuff out. And when we pull up the text editor, I will go ahead and paste it in so we can see exactly what's going on here. Some of this stuff we don't need. Like tiled version, I don't care. All of this stuff I don't care about. Tile width I care about. Columns I care about. Image height I care about. Image width. Those things I might care about. Spacing 0. Okay, so now that I have this, we need to have .image. So .image is so you'll see that it's the swell sheet.png, but we'll allow the file to specify the image. This needs to be the number of rows. I see columns there. I'm assuming rows exist somewhere. Did I miss it? Tile count 50. You can derive it from the tile count, I guess. That's annoying. Okay, so we have number of columns. I'm going to have to derive this. Bugger. Go away. What is your problem? I hate you so much. Let me do this kind of thing. Alright, I'm just going to write stop. Columns equals tile set of columns. They probably don't save the rows because you can do this divided by tile set, or I'm just super blind of tile count. No, tile count divided by columns. Yeah, so the tile count is 50 divided by columns is 5, so that results in 10, which is the number of rows we have. And now we can provide rows here and columns here to give us our grid finally. Now this thing is really driving me crazy. Okay, I'm going to get rid of this, see if that helps. Okay, whatever program. All right, now we have the grid as a sprite grid. At this point, we need to be able to read in the tile map. Okay. Tile map. JSON.loads. Open dungeon map.json. Read. Okay, save that out. We'll go ahead and print tile map. Switch on over. Python. Run the program. This is interesting. What happened there? Tile set is not defined. Let's see. I put title set, not tile set. Tile set, please. Much obliged. Much obliged. Missing one positional argument. Position. Okay. And could I have found that out some other way? Probably. Oh no. Oh, image requires position. That's what the problem is. And we're going to get 0, 0. Like so. Not open wall sheet.png. I need to move it over. Indeed. Not open wall sheet. Let's try this again. Mr. Wallsheet, where are you? Should have been in here. Okay. I put in images? Yes. There. Okay. Yeah, we need to update the file. I move things around. Okay. Tile set. New dungeon. Update some. So this should be images / wall sheet. And that should fix our problem. Hopefully it will. Load up the command line. Yep, there we go. Okay. We haven't done anything with the background yet, so still see the same background. Now we can see all of this map data. Width, height, we want that. And we also want, we could load the tile set this way too. Tile width, tile height. Yep. Alright, tile width, tile height will allow us to do some math. But we could have figured that out. Okay, most important part here though is the layers. So we want the first layer is data. Okay. And copy you. Oh, actually, we could just show this on the other half of the screen, right? This is the same data. Okay, we want layers. Okay, and the tiles. Tile indices. I don't know. I'll just say indexes. Should be from the tile map. We want the layers. And we want the first layer, which is 0. And we want the data. That should give us the list of all the tile indices. And we need a way to, I think we should convert these into, no, let's not do that here. Let's do that in the cell quickly. So get item is responsible for getting a row. We store the rows. Okay, we'll have to do this index, cell comment index. So what we need to do is we need to return the cell, self.cell, that corresponds to this index. And we're going to have a row equals index divided by self dot. We're going to need this to be height. With comma height equals self dot size. And column will be index modulo height. Okay, let's see if this makes sense. So what this is going to be is I'm going to be able to say we have 50 cells. Let's pull up Elegant to look at what we're talking about. What we have. We have 50 cells here. 0 through 49. This isn't 0, this is 1, this is 2, this is 3, this is 4, this is 5. They're just in order. However, I have them stored in rows and columns. I have a row, I have a list that stores each row, and then in that row I have a list that stores the image for each particular column. So that's the data structure I have. Therefore, I need to divide out the column. So, given that, if we have an index of 0, 0 divided by whatever is 0. 0 modulo anything is, 0 modulo 2 is 0. So 0 modulo anything is 0 as well. So there's no, with 0 there's no remaining. 1 divided by 5, well, so it's easy number. 1 divided by 5 is 0. 1 modulo 5 is 1. So we'll have 0, 1, 2, 3, 4. Yeah, this makes sense. Yep, the modulo is the column, the division is the row. Okay, yeah, my code makes sense. So here, we have the row is the division by the height, and the column is the modulo by the height. I think we'll want it by the width. Let me just think about this for a sec. The width is 5. Yeah, we want this by width. Modulo the width. Alright, okay, cool. Now, we can use this to go through our tile indices. So for tile index in tile indexes, We want to blit onto the background. Okay, background, dot blit. Tile set grid dot index of tile index. So this is a sprite. You want to get the image of the sprite, and we want to do this at a particular location. We'll say x comma y, and we'll set up x comma y in the loop. X equals 0, y equals 0. Okay, x will increase by the tile size, which is 64. I'm going to hard code that right now. If tile index remainder is 0. A remainder of the number of we need to use the tile set information. This is going to be tile map. Sorry, we want to use tile map information. This is going to be the width of the tile map. I think it's just width. And this is 0. It's divisible by the width, so we want to adjust the y-axis by a tile. Like that. It's width. We are correct. And that should do it. Let's check it out. Now wait, hold on 1 second. We don't want to overwrite it after we've done it. Let's do this. Do this like so. Equals surface 20 by 720. That's our surface, and then background. Dot fill. We'll fill it with black. This will blank out our background before we do anything. So if nothing works, we'll get a black screen or an error. Hey, we got an error. Awesome. Okay. We got an error because I did not do the right thing. So, call missing to required arguments from column. Yeah, I'm a dummy. So, I'm back to Emacs. Time to fix my mistake. As usual. Yep. Row, comma, column. Save that out. Try again. So surface rectangle outside of surface area. Oh, okay. Well, I will omit drawing the last row. How about that? And we can only have, what was it, 11 by 20, so 220 tiles. So I'm going to limit this to 220 tiles. And I will limit it to 200 tiles. Still having complaints. Okay, what are the numbers now? Now I'm kind of wondering. Let's do 20. How about we do 20 tiles? Okay, it's still giving me a paint. What the error it's giving is this error. It's saying that I can't make a subsurface in an area that is outside of the surface that I'm working with, which makes sense. But we need to figure out why that's happening now. Okay. Do we need to go to line 137? 137. Yep. Correct. Row, comma, column. And cell. That should print something in at least. So I can see what it's complaining about. Cell 06. Okay, it's complaining about 6. It's probably too wide. And 64 times 6. Oh no, it's outside of the grid. Yeah, it should only go up to 5, so it's indexing that incorrectly. It should be what, be 0 through 4. Okay, something is up here. I'm missing something. Oh, rows and columns. This is different. We want this to be number of columns, columns. That is just Mr. Stupid Head. Self.columns. Okay. Surface object. Okay. Has no attribute image. And it's complaining about this, the original blit. Since it's not a sprite, it's a image, we can just use it directly. Background dot image. More of this stuff. Okay. So we have some information. So let's go ahead and try to render more. Uh, 220. Is that good? Okay, what happened? Something's not happening with the Y. Yeah, here, yeah, I, and enumerate. I think I showed what enumerate does before. If I haven't, I can show now. Enumerate does this. It enumerates the list. So if you have a list of a B. C. Yeah. B, comma B, comma C. Can you enumerate the list? And this of that. So you can actually see it. It'll show you that this is the first element. This is the 0th index, second index, third index. My problem is I was going through, I was using the wrong thing. I need to use this index that I'm adding in here. Alright, back to Emacs. And we need to do a modulo of, we need to do I modulo this. Then we should advance the Y. If you think about it, it's going to be 0, then it's going to be 1. Oh, wait, 0 should make this 0, and I'll advance it. That. 0 modulo 0. This is 0. Oh, wait, 0 modulo 5 is 0, yeah. So this may draw a little weird, but it should be better. We can fix the issue. And now we're getting outside of the surface. Do 200. I think the last row is trying to be drawn. Yeah, 100. And then this would be game. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So 21, can you handle 21? Kinda. Oh. That's the problem. Okay, that's kind of what I expected to see. Was it be offset by 1 the first time around? 100. X needs to start over again. X equals 0. That's drawing something. Not correct, but it's something. Okay. The tile index is grabbed from it. That's correct. And we're going through. Let's look at the debug output here. Oh, that's not right at all. Oh, maybe it is. Maybe that's right. Let's see. 6, 3. Show. Okay, so 6 should be the next column. So 1, 0. Not 1, 1, it should be 1, 0. So I'm seeing 1, 1. 6 is saying it's 1, 1. 3 is 0, 3, that's correct. But 6 should be 1, 0. 0, 1, 2, 3, 4. 5 needs to be 1, 0. Yeah, 5 is 1, 0. So there's a problem with the cell grabbing code that we want. Index divided by columns. Okay, let's go back to the max. The row is definitely the division. We have to do the index minus the row. Maybe no. No, that doesn't make sense. An index of 6 would be 1, 0, not 1, 1. So 6 would be, 6 modulo 5 is 1 remainder 1. Yeah, so it should be a remainder of 1 in modulo. But this seems wrong. It's wrong because it's off by 1. This would be a lot easier if we just had a list of tiles and maybe did the cells a different way. I am not sure. It's not correct to just subtract 1 from the column. I don't think. It's 5. We have 5. The column can be 0 through 4, which is correct. But 5 modulo 5 should be 0. This is a little bit of a thumper, but this should be easy. So what are our assumptions? Our assumptions are that you have this data here. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So if we modulo 5, that should be 0. 0, 1, 2, 3. So, oh, 0, 1, 2, 3, 4, 5. Okay, 6 is the. Wow. All right, I'm actually not terribly sad about that. That should be okay then. I actually made a mistake in my head. Oh, well, good to know. So this is why you test your assumptions. Because you could get yourself in a little loop. Okay, so that makes sense. Now let's see why it doesn't look right. Probably because it's not displaying correctly down here when we drew it with our little gritty thing here. Not that great. Alright, if tile map has a width of, what did it say, 22? And we are divisible by 0. And the modulo is 0. It means we're divisible by whatever we're doing. I is divisible by 22. We should then advance it on XY and reset the X. That makes sense. Then paint, then advance, then paint, then advance. Let's just print out XY so I can see what's going on when I run it. Okay. Pull it up. Keep going. Okay. So 0, 0 is a 6. That makes sense. Okay. 0, 64. Well, that's wrong. 64, 64, 128, 64. All of these are making sense until then it resets to here, 0, 128. Okay, that makes some sort of sense. And it keeps doing that. The first row is not being done quite right. Oh, you know what I could do? I could do rows and columns in the loop and just increment the index. That'll probably be easier. Yeah, let's try that. Okay. We're going to go for row in rows, for column in columns. That'll give us our rows and columns of the map. Now that'll give us our rows and columns of the tile set. And we need to get map row and map columns. Map rows, map columns. Do this. Map rows. Tile map. rows, map columns, tile map of columns. Okay, good. This makes things a lot easier, because all we need to do now is say column times 64, row times 64, and we'll let it count. The only thing we need to do is go tile index well, we need to count an I. We need a I equals 0. Tile indexes of I. I plus equals 1. That should make it easier. Let me do range. Range. Dealing with numbers, not lists. Range converts that into a list. Then we can iterate through it. Look at the tile index that we're dealing with. Yeah, okay. Good. Let's do this. Excellent. I knew something like that would happen. Okay, well, we're down here. We can find it. So width and height. Width and height. This is height. This is width. And next. Updated these guys to height and width. Okay, well, that's certainly better filled, for sure. Okay. It doesn't look right, but it looks decent, I guess. So 0 tile gets done. Go up here. Six, 3, 3, 3, 3, 3, 5. 6, 3, 3, 3, 3, 5. Okay. So what it's doing is 6, 3, 3, 3, 3, 5. That's what it's drawing right now. Okay, and when we look at it, this isn't 6, this isn't 3, it's wrong. I don't know how else to say it. It's wrong. Wrong, 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 wrong. Column times 64 is the X position. That is correct. And rho is the Y position. That is correct. And you multiply by 64 for each effective tile. Yeah, that's correct. That's so weird. That's looking like that. And we can print that out if we want. Yeah, sure, print. You want, so you want the index, and then you want X, comma, the Y, dot format. And you want these guys, index of I, comma, column, comma, row. That's fine, I don't need it fully expanded by pixels. And next, I just added in this print line here. And we're going to go ahead and try it out. See what it says. Mr. Repo, if you don't mind, go to the top. Thank you. 6 at 0, 0, which is cell 1. 3 at 1, 1, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. I know that tells me something bad. No, that's right. Actually, that's correct. This is X. Yep. This makes sense. I'm going to make you only do a certain amount of cells. One of the things you can do to debug something is to reduce the number of things you can have happen. So what I'm going to do here is, after the first one, I'm going to return. So we can see what the first thing prints. And almost time dot sleep 5. And import time. What this is going to do is it's going to put the game to sleep for 5 seconds so we can see what happens. So it went away too fast. I don't see anything. That's because we're not going to see anything. Sure can do. Grr. 1. Map rows equals 1. Map column equals 1. Try that. Okay. That printed a cell should have been correct in the correct place. Now we know that we can pinpoint the problem. It seems like the problem is in the actual grid when we made the grid. The sprite grid that we made here, it doesn't look right. Okay. So sprite grid should have a sheet. Should be able to blit out this sheet to the screen somewhere. Let's split the tile set grid dot image or dot sheet dot image. I believe that's what we want. We want to blit that to the screen. Surface object. Okay, so that's already an image. Don't need that then. Good. Ooh. Get rid of this. That. Don't want to blit the main character. And we don't want to use that logic right now. We just want to see the sheet. 0, 1, 2, 3, 4, 5, 6. This is that corner piece. Interesting. It is that corner piece. Huh. Okay. Let's make sure that's correct. 6 is that corner piece. It just looks really weird. Six, 3, 3, 3, 5. Huh, maybe all this is correct. And I just don't have the right map. I thought I had the map correct. Look at the tile editor. Open. The dungeon map. Open that. Yeah, this is correct. It looks fine in the tile editor. Let me see if this file, what are the properties here? Preferences. You know, I hate doing this in a video that's supposed to be showing how to do something, and I haven't used this in a while, so I apologize for doing stuff like this. Okay. That property is what I wanted. Custom properties, no background color. Whatever. Dungeon map is here. This is development, right? Move it over, copy, replace file. Let's actually get this back that we had before. So it draws things. Yeah, we can just have that. We wanted to see this working. No, not that. We want the background here. Background. Let's see the screen. So that was that corner 6. Yeah, I found that very confounding. Very confounding. Maybe it's off by 1. Maybe they are starting at 1 and not 0. Yeah, that has to be it. That has to be it. They're messing with me. Okay, in that case, how could they do that? Yeah. Yeah. -1 right here. They violate programmer ethics, I swear. That looks good. Let's get rid of these. Again. Okay. We're getting subsurface grid thingy here. Oh, it's cell -1. Oh. Is there a 0? There's a 0. That's nonsense. So it's not off by what's going on here? Oh, there's zeros in there. What is a 0? 0 might be nothing. Okay, so 0 means nothing. No tile. They have to have a way to represent no tile. Okay, that's what they did. May 0 represent no tile. I think this is correct. Alright, we don't want to let, so we'll say tile index equals this thing. Tile index, this one. If tile index equals 0, and does not equal 0. I'll get that working in a second. If it's not 0, then we split it. We're going to skip 0 tiles. There we go. It's a level. Yay! Thank you. Now I can put the thingy back. And I can walk our character around in a level. Draw is not defined. Draw is not defined. You're not defined. Yeah. Draw. Well, there we go. We have a character going around a level, going through walls. But it's working. Alright, this has been a long episode. However, we got the tile map into the code. We got it printing. We got it in the background. We'll have to figure out how to scroll it and also figure out how to set up collision so Link cannot just walk through walls. Alright, those are the things that we need to do next. Hope you enjoyed. See you next time.